Good morning, lovely 12s. Right, guys, here we go. We are on to the second lesson now of integration. Unfortunately, I'm not with you again, obviously, but hopefully we'll be back in the classroom really soon. But the title for today is Definite Integrals. Now, yesterday, or last day, you did for me what was called an indefinite integral, and that's where you saw this symbol for the first time, this big, long S-like symbol, and the dx. And I told you that they went in a pair and that you'd integrate whatever was in the middle. At the end of those, what you did is you put a plus c on the end, and pretty much that was that. So it was just a fancy way of undoing differentiation, and it was a fancy notation, but it's a really useful notation you'll learn soon. But it was just kind of a fancy notation. So the difference between that and what we're doing today is those are indefinite integrals, these are definite, and these have these little numbers there. See the 0 and the 4 on the bottom of the S and to the right and small, and the little 4, which is to the top of the S and little and at the top, okay? So it's important that you write them out neatly and nicely. So 0 and 4. Those guys, my lovelies, are called either the bounds of integration, which is what I always call them, the bounds of integration, or they're called the limits of integration, where that, 0, is the lower limit and 4 is the upper limit. Essentially what it's telling you is that you're going to evaluate the integral at the value of 4, then you're going to evaluate the integral at the value of 0, and then you're going to take away those two values. Now, we'll learn this later on, that you're actually finding an area under a curve, which is super important. Like, I can't even stress that enough, how important that is. That's how the whole of physics runs, because of the area under curves. And even in things like business and finance, you're going to do areas and stuff under curves. And statistics, all the distribution works as areas under curves. And yeah, very exciting anyway. So yeah, should I just show you how to do it? Stop babbling on. That sounds like a good idea. Okay, so check it out, 0 to 4. All you're going to do, my buddies, is at the very start, integrate it just like normal. Okie doke? So just do it in the normal way and just ignore the 0 to 4 business. So you guys know already, let's go purple. You guys know already that we're integrating the blue bit between the two black symbols, between the S symbol, the integration sign, and the dx. So here we go. What's the rules? Well, let's do it. Raise the power by, well, 3's chilling, so leave 3 chilling. I'll raise the power by 1, x cubed divided by the new power, 3. Perfect. Then you're going to go plus, and here we go. Raise the power by 1, x to the power of positive a half, divided by the new power, divided by a half. Now, I'm going to let you in a little secret here. I'm going to put a plus c, but this might well be the last time we do this. Here's the one difference. What you're going to do with the definite integral, which means it has the numbers in, is it just needs to now go inside of a square bracket. A big tall one that covers up the whole of the fraction, or the whole of the equation, just like that. Put your 0 and 4 here now. Done. Okay, little tidy, because it's still worth tidying, so get that square bracket going again. First part just becomes x cubed, because the 3's cancel, times the top and bottom of this one, the second fraction here, by 2. So little times 2 times 2 times 2 times 2, gone off the bottom, and you're going to end up with a plus, yeah, it is a plus, plus 2, and it's x to the 1/2, 2 root x. Cool? And square bracket, 0, 4. Cool. Well, that's it. I forgot the plus c, plus c, plus c, plus c. Now here, plus c. Now here we go, guys, 0, 4. What you're going to do now is the final thing is, remember how I said a moment ago, you're going to take the upper limit, or the upper bound, and you're going to take from it the lower bound? It's time just now to put the number in. Here's how you show that neatly. Open a circle bracket now, and in it, we're going to replace the x with 4. So we're going to end up with 4 cubed, take away 2 times the square root of 4, plus c. Then close the circle bracket. Okie doke. Take away, and do the same thing now on the 0. Open a circle bracket, 0 cubed, plus 2 lots of the square root of 0, plus c. How exciting. So that's what we've got there. Now, ooh, do I want a calculator or do I want to go with that? I'm going to go with that. I want to be brave. 4 times 4 is 16 times 4 is 64, I think. So we're going to get 64. Take away, square root of 4 is 2 times 2 is 4. Take away 4 plus c. The second bracket, the minus, I'm just going to copy it. That's going to be 0. That's going to be 0. And this is going to be c minus c. Well, oh my god, lovelies. Oh, the c's go. How exciting. Okay, and that leaves us with a final answer of 60. So say that this was a question that you were actually finding the area under a curve. The area under that curve would be 60. Say it was a question that you had a graph of acceleration. The answer to that would be 60 meters per second. You'd get a velocity, or you'd get whatever I'm trying to say. Yeah, you'd go one level up from it. Yeah, there we go. So it's got a practical meaning, which we're going to talk about. Excuse me, which we're going to talk about a little bit more later. So yeah, how exciting. You've got an answer of 60. It's a whole number. Brilliant work. We got it. No problem. So yeah, here's what we got. Check it out. Can you see that the C's canceled out? Oh my gosh. Guess what, buddies? That's going to happen every single time because no matter what, my lovelies, that this part is equal to, you're always just going to get like a plus C at the end. Yeah? And that plus C is always going to wind up there, but then by its very nature, it must also wind up there. Since we subtract, they end up canceling out every single time. You're guaranteed for them to go. Now, if they've gone, then there wasn't much sense in actually writing them in the original question. So here's your big shortcut, guys. From now on, if it's a definite integral, go ahead and bin off the plus C. But that's a dangerous game sometimes, because you definitely need the plus C for indefinite integrals without the bounds. But you don't need it for the ones with the bounds. So for instance, like this one that we're about to try. Cool. Right then, so if you think you've got your handle on it, why don't you push pause right now and have a little go. And yeah, I'll be back to you in a sec. So push pause and have a try. Go. Okay, and you're back. Let's have a go. Here we go. Check it out. What we're going to get to start with is, oh dear, it's not ready to go. There's a squared in it. Drat. That means we've got to actually tidy this bad boy up first. So, oops. Oh, I've got the wrong color of pen. Tidy this guy up first. Well, here we go. Integration symbol then, because we're still tidying. 0 and 1. This is going to be like the bracket squared, so I'm going to actually write it to make sure I don't lose anybody. Take away 1, and it's going to be x to the 1/3. Take away 1, like that. Dx. So I've shown an extra step there. You're welcome to skip that if you like. I just don't want to confuse anybody when I'm trying to teach you online. And here we go. Ready to times out. X to the 1/3, x to the 1/3. You add the powers. It's going to be x to the power of 2/3. Then you're going to get minus x to the third minus another x to the third. So it's minus 2 x's to the third. And the final one is a minus 1 times a minus 1, which of course is a plus 1 dx. Don't forget that because you need it to make sense. Cool. Next step, what we're going to do now is actually integrate. So here it is. Square bracket, don't forget, because we're doing definite integrals now. Raise the power by 1. That's like adding 3 over 3 to it. So this is going to be x to the power of 2 plus 3 is 5 over 3. Divide by the new power, 5 over 3. Take away 2, because it's chilling. Add 1 to the power, so it's going to be plus 3 over 3, so it's going to be x to the power of 4 over 3, divided by 4 over 3. Cool, cool, cool. This guy here is just plus x, okay? Now, I should put a plus c, but will I? Nah, why not? Why bother? It's going to get cancelled anyway. So, 0 and 1. Happy days. Cool. A little bit of a type. A little bit of a tidy for us now, my lovelies. So here we go. Times the top and bottom by 3 on this bad boy. And we're going to get 3x to the power of 5 over 3 all over 5. This one here, I'm going to do some cheeky cancelling. Once and twice. And then I'm going to times the top and bottom both by 3. So that means it's going to be minus 3x to the 4/3 all over 2. This guy stays plus x square bracket 0, 1. Now, here we've got it. Final step is we're going to pop in the numbers, okay? Now, it was really kind of them to give us 1 and 0, and they often do, because that means it's going to be nice and easy to put in. It's just going to be 3 times 1 to the 5/3. Well, that's just 1, right? 1 to the 5/3 is over 5. Take 3 over 2 plus 1. Just say, oh gosh, stop skipping steps, I'm being naughty. 3 times 1 to the power of 4/3. That's perfect. Plus 1. Close the bracket. Take away. Now, I do want to cut to the chase here. You know this is going to be 0, right? If you put 0 in, so I'm just going to pop it as a 0 rather than writing it out. Second thing's 0 as well, and so's the third thing. So, by golly, that saved us a couple of steps, didn't it? Sweet. Okay, now here you go. You might want a calculator for it. It's just going to be 3/5 take away 3 halves. 3/5 take away 3 halves. plus 1 equals, I got a 10th. I hope that it's a 10th anyway. That's what the calculator says. So, yeah, great. Here we go. So that's just, the first thing is just going to be a 10th. So that's a 10th. And the second thing's 0. So what are we going to get? 10th. Final answer. Like a boss. So happy days, guys. Not playing games, definite integrals. Cool. There you go. A lot harder now, but I say a lot harder, but it's not way, way harder. You should have a go at it. So push pause on the video, see if you can do this. It says given that p is a it says given that p is a constant, and this integration symbol here, um, yeah, it equals that. So essentially, it's done the integration for you, and p is a constant, and it said the answer makes 4p squares. It says show there's 2 possible values of p and find those values. So integrate the left and see if you can work it out. It's a bit of a problem solver. Ready? Go. Okay, let's see how you got on. Okay, a little bit harder this time, but it's not horrendous at the end of the day. So let's do it. So integration symbol, I'm just going to write it out to make me some space here. We're going to have a 2px plus 7. Oh, I wrote 7, I wrote d. Plus 7 dx. Now that has to equal 4p squared. Okay. All right. Sorry, lovelies. My voice is still not quite back yet. I'm still a little bit ill, it seems like. Okay. Sorry, excuse me again. Right. So here we go. We have to integrate. Now, you remember how a minute ago it did say that p was a constant, yeah? Well, if p is a constant, it means it's chilling, yeah? That gives it an excuse to chill. So 2 and p are both chilling, and now when we do the integration, check it out. 2 and p, both chilling. What happens to the x, though? Well, x squared, divided by the new power, 2. What does 7 integrate to? Well, just 7x, because that is what you'd have to differentiate to. That runs between 1 and 5, and the answer has to equal 4p squared. It's just algebra now, so we just have to go in and crush it. And even still, look at this. I'm even going to skip a step. Those cancel away, don't they? So it's just px squared. So in my first circle bracket, I'm going to be left with p times 5 squared plus 7 times 5. And that's the first circle bracket. Take away, and now put your lower limit in. You're going to get p times 1 squared plus 7 times 1. Close that circle bracket. Still has to equal 4p squared. Cool. Right, so let's start tidying. Here we go. 25p plus 35. Take away p, take away 7 equals 4p squared. And by God, my lovelies, what is it almost formed? A quadratic! So, so be quiet because I'm hurting my voice. Okay, so what we will do is we should go over to the, move everything to the right, okay? So here we go, I'll have a 0 here, I will. 25p, take a p is 24p, so it's going to be 24p, so it's going to be 4p squared. This is going to be plus, this is going to be minus 24p. 35, take away 7 is 28, so we're going to get a minus 28 also. And that's brilliant. Okay, they're all even. And they all divide by 4 as well. That's a mega result. They all divide by 4 too. So let's divide by 4. P squared minus 6p minus 7 equals 0. Sick? Well, guess what? Just solve it now. Two numbers that times to make minus 7, but they add to make minus 6. So those are going to have to be minus 7 and 1, surely. So p minus 7 and p plus 1 equals 0, which means that p is 7 and p is minus 1. Well, by Jove, my lovelies, we've answered the question. What values of p pull it off? Well, those two values there, 7 and minus 1. So hope that's okay. I'm gonna get you just to practice a bit. So 297, question 1 to 8. This video's been 15 minutes, but so far. But I bet you guys have probably run me in at least 1.25, so that's cool. So I would say don't run your practice at 1.25 and make sure that you get some of this done. So maybe spend 10 or 15 minutes now on this. But the video's not over, so I'm going to tell you to pause in a minute, and we're doing one other topic too. So 10 or 15 minutes on this. Ready? Pause, go. Okay, and you're back. So I'm hoping now that you felt like you could you could do those. So I hope that that was okay. One final skill for today, and it's not actually a big, huge skill. It's just kind of another minor skill. We're just using our skills now in a practical way. So title now is finding the equations of functions. Now, you know how at the very start when I first taught you integration, when I first told you about it, I was like, it undoes differentiation. Well, that was all well and good, but we ended up with this stupid plus c in all of them. So that's kind of disappointing, because if there's a plus c in all of your answers, well, you've not actually got back to the original function, right? You've got back to the original, to nearly the original function, but with a plus c. So say the original function was x squared, you've got x squared plus c, like not x squared plus 3 or 5 or 9 or take away 6 or whatever, like maybe it was x squared take away 6. You don't actually know what that is. We haven't worked out what the c was, so it's kind of disappointing. You've not locked in on a particular curve, a particular solution if you want to be really posh about it, but rather you've locked in on a family of curves, which is called a general solution. You do not need to know those words. That's further maths or whatever, but yeah, you've locked in kind of on a family of curves, but you don't actually know what C is. So all we are going to do is just try to work out what C is. We're just going to try to work out what that number is at the end. And so in order to do that, check it out. It says the curve C with the equation y equals f of x passes through the point 4, 5. Given that f primed of x is equal to that, so there's our gradient function there. Given that excuse me, given that f prime of x is equal to that, find the equation of c. Well, guess what, guys? See that 4, 5? They call this guy here an initial condition. Okay, now if you've got an initial condition, it's all you need. Yeah, condition. I spelled that condition. Yeah. Okay. If you've got an initial condition, my lovelies, then you can get what the c is, because you'll know that x is equal to 4 and y is equal to 5. And so if you start with your original equation, then you can actually get what c is. So it's not as bad as it looks. So let's have a little try. So to start with, my buddies, f prime of x is equal to all of that noise over there. X squared minus 2 all over the square root of x. Well, you can tell straight away it's not ready to go. If you want it to be ready to go, you've got to get it in a nice format. So here we go. X squared minus 2 all over x to the 1/2 to start with. Now, step 2, buddies, is we're actually going to tidy it up. So here we go. F prime of x is, and I'm going to take the x squared and I'm going to divide it by the x to the 1/2. So 2 take away 1/2. It's like 4 halves take away 1/2, so it's 3 halves. So it's x to the power of 3 over 2 minus, and I'm being really cheeky here and skipping steps, a chilling 2, x to the power of minus 1/2. Do you guys feel cool at that? Good. So here we go. We're now ready to undo that differentiation, which means we're ready to integrate. So I'm even changing colors to show you, which means now we're not doing f prime of x anymore, but rather f of x. And f of x then will be the integral of this. X to the 3 over 2 minus 2, x to the minus 1/2 dx. And yeah, no bounds on this one, so we're going to end up with a plus c, indefinite integral. F of x equals, and let's do it, raise the power by 1 divided by the new power. So 3 over 2 is going to be 5 over 2 divided by the new power divided by 5 over 2 minus 2, which is chilling, x, add 1 to the power, positive 1/2, divide by the new power over 1/2, and plus c, because we do have bounds in this one, or we don't have bounds in this one, which means f prime of x is equal to, times top and bottom both by 2, 2x to the 5 over 2 over 5, minus 4, it's 4x to the 1/2, I'm going to call it 4 root x, so I like having the root x in when it's only just a single root, simple. Okay, and there you go. Now, that's what you know how to do so far, okay? This is the nearly answer. The curve, for sure, is going to start with this, but we don't know what c is. So, since c can be anything, what you're actually going to find is, say that this curve looked like that. It doesn't, but let's say it did look like that. We just don't know, but it's certainly going to be parallel with it, okay? That's what the plus c is, because you know the plus c is actually doing a vertical shift, yeah? Since we don't know what it is, it might be like a plus 10, in which case the curve will be up there. It might be a minus 100, in which case the curve will be down there. But it'll all have the same shape, and that's what is kind of useful, but not perfectly useful. So we need to get what's called a perfect, or a particular solution, which means we have to actually put the values in. So here's what you do. You're going to go at 4, 5. Now, you guys know already that f of x is secretly like a y, isn't it? So we'll just pop that in. 5 equals 2, open bracket, 4 to the power of 5 over 2. See what I'm doing? I'm just putting the numbers in, right? Over 5, take away 4 times the square root of 4 plus c. And that's what we got so far. Okay, so, oh my god, do I want to do the calculator or do I want to go mentally? Here we go. Oh, I think I want to go calculator. Sorry, buddies. Okay, so we're going to go 2, 2 times 4 to the power of 5 over 2. Should have got that. That's all right. 4 to the power of 5 over 2. Divided by 5, 64 over 5. So 64 over 5. This is going to be square root of 4 is 2 times 4 is 8 plus c. Everything over to the other side to work it out. So here we go. It's going to be 5 take 64 over 5 plus 8. 5 take 64 over 5 plus 8 equals c. Fifth. C is a fifth. Cool. Nearly the answer then. All you gotta do is bish bash bodge these guys together, bish bash bodge, and you've got it. So final function f of x equals 2x to the 5 over 2 over 5 minus 4 root x, and then plus a fifth. And now if there's a whole great big family of curves, you know exactly which one is yours. All of that stuff I'm being a bit technical with. Essentially, all you need to know is that your c is findable now. You just have to find C. And that's it, buddies. You've got to the end. A final little practice for you here. Just do a little bit of a mix of them. It's just, these are all just finding C questions. So that's the end of the video. So make sure I'm not going to make you hand anything in again today. No handing anything in, because I should be with you hopefully for the lesson after this one. And yeah, that'll be perfect. So have a little try through those, do a mix, make sure you don't not do it. They're on your test. You definitely have to do it. And like I said on the thing, this counts as your lesson, so I'm not going to reteach it the minute I get back. So do your best to learn it. Come to math support if you're stuck. And that's it for me. So see you next time. Bye, buddies.